forward to sharing tonight's presentation with you. Thank you so much, Dr. Paulsen, and welcome. And when you're ready, you can share your screen and we'll begin.
Thank you, Elizabeth. Thank you, everyone. And the first slide, it would be info@cadasilconsortium.org, and it would have a hyphen in between here, and this would be the .org. So it would be info.
In fact, I think your last slide may have that.
Oh, yeah, and I think the last slide.
So if you want to scroll that, you can show that real quick.
Yeah, let me see. Well, no, because that'll mess up my play from start.
Oh, okay. So let's just keep going, and then there'll be opportunities at the end, and you can always even email us anytime. Really, it doesn't even have to be tonight. We're always here and happy to address questions. Thank you, Dr. Paulsen. Okay.
Well, again, thank you for being here, for volunteering. We're really here tonight to say thank you, that this team effort has been phenomenal. You know, we were under the gun and we were nervous for a while, but it is quite remarkable what we've been able to accomplish as a group. So the first and overriding thing and reason we're here tonight is just to say thank you. Wow, it just has paid off. We're thrilled to have reached the 500 baseline participants, and it means we can go back in and ask for our extra years of funding that we were awarded in the grant, and we hope that NIH will be as impressed as we are. And I already have indications from them that they are impressed. A couple of them already said, gee, I didn't think you were going to make it. So I'm like, well, there we go. We got it. So that's a big thank you. And this just gives you lots of detail, but I want to point out a few things. It has the site along the side and the number of baseline participants. But you notice we did go over the number of baseline participants, but I want to share why, because we needed to make sure that we had MRIs in the baseline participants that we can analyze, because the power was calculated based on people with an MRI scan. Given that it's a neurological disease, hence a brain disease, we need to watch very closely what changes occur in the brain. Many of you may have noticed that when you complained about any TIA or stroke symptoms, that they probably ordered a brain scan on you. So that is a hallmark piece of information that people use for any type of vascular contribution to cognitive or motor or sensory decline. So we really needed to go over. We're going to continue to follow everyone, but some of the people that weren't able to do an MRI scan, we might just follow you remotely, and we'll see if we can get additional funding to follow you in person in future years of the grant. The focus now is really on visit twos. We have already seen 139 visit twos. They're all coming in right now. So this will be important for everyone to continue to get their visit twos in. We even have some visit threes starting this fall. So we're well on our way to accomplishing our goals. And I'll be talking a lot about our goals during this presentation. The other thing that's on this slide shows you we're already in touch with additional people, because we didn't know when we would hit this 500 with brain scans, but we are going to follow through. If you're already scheduled and in contact, we want you. We'll enroll you. Anyone else, we're going to keep in touch with you. We've already run into people who are having difficulty with travels, who may have had additional things occur in their life that makes it difficult to follow up. So we are going to maintain that we have 500 active MRI participants at all times. So we will be continuing to bring people in as we need to. These last three columns are additional grants that we were awarded. The first two were from NIH, and the last one was from the FDA. And so the Food and Drug Administration is the organization that approves treatments for disease. So to get on their radar was a really big event for us, to write a grant to them and for them to say, this is important, we support you, and we want to help you do this. So this retinal imaging grant is from the FDA, and they're already on board, as well as the NIH, in multiple grants to support this initiative. So this is a big thank you to all of our fabulous sites. These are your investigators. You will see it has all the sites on this little map over here with the little colored dots. And then we have all the neurologists that are listed down here for each site. A few sites do have more than one site investigator. As you notice, Brown Butler has Dr. Steve Salloway and Ted Huey. San Antonio has both Sudha Seshadri and Sarah Doyle. And now our new site moving from Georgia State to Emory has Dr. Chris Murthy and Fadi Nahab, if you've already met them. So we're bringing all comers, everyone who's excited about the study and wants to get involved. We're definitely excited to have them. And my co-investigator is Michael Geschwin at our UCSF site. We do have a new additional new staff who is reviewing all of the cognitive data for us and will be looking at all of the neuropsychological data, and that's Dr. Barb Fisher. So we want to welcome her as well and let everyone know that she'll be helping us make sure that the measurements are as good as we can make them. Okay, so just to go over quickly what we have, I'm not going to do a very thorough data overview today, but I will give you as much as I can give you. The primary limitation is, we will take anyone in the study, even if they don't want to know their genetic analysis. We have funds, we can pay for their genetic counseling, we can pay for their CLIA certified genetic tests, and these people then, that information will not go back to the sites. It will not be publicly presented. So this group is, at this point, not looked at all, because I need to get the numbers high enough before I can even share them in the group data, so that we can respect the confidentiality of everyone who was willing to be in the study but didn't want information back about the study. So that is quite a large chunk of our 550 is 127 who is using that genetic counseling to be in the study. We do have 112 people who do not have a gene mutation for CADASIL, but as you know, they're all from a CADASIL family. So they're all from a documented family that does have someone with CADASIL, and they were willing to be our comparator group. So we also want to give a shout out and thank you to all of our family members who enrolled in the study, even when they were gene negative. And our largest cohort, of course, is our group who do have a gene mutation for CADASIL, and that was this 311 group. And, we're assuming this unknown group will filter into both of these groups, so it'll probably just expand them. I just did a little summary of what the data looks like at this point. This adds up to our 550. And it's still ongoing, so that number will continue to increase. I think it was even larger in the slide than it was on this slide. But in general, it's as expected for the most part. The age of our participants is around 50. We have people, though, from as young as, I think, boy, I should have double checked, as young as definitely 20, but I think even 18, up to over in their 70s and 80s. So we have a really nice group of people, a little highly educated, but in average, but we do have some nice variation there. And we're working on getting the most diverse cohort so we can be representative, because as you know, a disease can manifest very differently in different ethnicities or different races. So we're happy that we do have 11% that are non-white. And we'll continue to try to take all comers so we can really best represent the entire disease spectrum. Now, not surprisingly, everyone has some neurological, which might be sensory, motor, cognitive, or psychiatric symptoms, which could be symptoms of mood or interest and activity and apathy. And then our group with the mutation does have a higher number of those at start. The number of onset, as you know, anyone in a CADASIL family is going to count anything as the CADASIL onset. So even our negatives have had symptoms. And this is something we expected, and which is why it's so important to always have a comparison group. Because what we're measuring are brain behaviors, and we all have brain behaviors. We all drop things. We all have days where our gait is a little wonky. We all can have abnormalities in our sensation and our motor and our thinking style and our mood. So we need to always have a comparison group. So we're very thankful for that group as well. The Montreal Cognitive Assessment is the primary assessment that I started with, and that is solidly very intact for really most of our group. We have such a great group, but I think the only thing is about our group is they are really a pretty high functioning, smart, well-educated group. So we need everybody, but this isn't bad news. We're still going to get the information we need. At this point, they're all doing pretty well. The modified Rankin and the functional capacity scales show that it's just a very subtle functional impairment that people are perceiving in their lives overall. We have a very just 1 point elevation on concern about whether people are able to do their normal functioning. And this is only 2 very points, resulting in a very low score for functional capacity. So our group, again, is a pretty functional cohort. I think the most striking difference on this first peek at data is really, even though people perceive that they have the social support network that's identical between the 2 groups, that we see that the people that do have a gene mutation for CADASIL aren't participating as fully in their social life. That is to be expected. That's why we have measures like that. But we will pay attention to that and ask if there's anything we can do to help with that. To keep you socially active tends to be one of those protective factors that can help against cognitive decline and to keep you as active as possible. So that's something we'll continue to pay attention to. And our data course sent me a little summary for tonight's overview as well. They sent me, I think it is 1,200 pages of data graphs to show you. And so that's what we'll be doing tonight, 1,200 pages. No, we're not going to do 1,200 pages. So it's 600 pages, and they sent me 2. So instead, I'm showing their summary slide because as interested as we are, I don't think we want to go through every variable. And as you guys know, there's a lot of measures that we're looking at for this first in North America ever look in humans at CADASIL. So, but just at enrollment, already at baseline, we can show the marked small vessel changes in our neuroimaging. Perivascular spaces, we have the increase of those clusters in our scans. We have a much larger white matter hyperintensity burden in our cases than in our family members. They also, as I showed you, have a little bit greater symptom severity and a little bit reduced functional capacity. The most cognitive slowing, as I shared, it's fairly mild at this point, is on speeded timed tasks, which is what we see pretty much in every brain insult. The first thing that happens is the brain works very hard to rewire itself and get you to the answer that you want. So what happens is it uses different circuits. It uses a different route, if you will. It might be a detour sign. If you were trying to get, somewhere in the car, that detour might take a few more minutes. And that's what the brain really tries to do, because the brain is always working for us. And so far, whoops, what did I do? So far, what we're really just seeing is that it might take a little bit longer on a few tasks. The disability is really what we talk about on functional capacity and mild elevations. Primarily, these are in just mood, like saddened mood and anxiety. And they're not really high, they're just subtly high. So we will, of course, always follow those and try to do our best these are treatable symptoms, many of them. So do talk with your physicians about if there's anything that you feel like you can perform better. We definitely want you to get every treatment. These are all highly significant. So it just validates that the study is doing exactly as it is supposed to do. So just to remind you, I'm bumping something, aren't I? Okay, I got to be careful what I touch. Just to remind you, it is a 5-year multi-site observational study. It is to follow Notch3 carriers and non-carriers. Our goal is 500 persons that we follow over time. We would like to do 3 visits for everyone. It's so essential that everyone that's in the study is willing to come back in the study. Because as you know, you can't test whether a treatment is helping you if you don't see what it does over time. So, and we will be talking more about that in this presentation, but also the importance of having people repeat their data is so key in finding new treatments and interventions to make lives better for people. So we're really now going into our 2-year visits. We're starting some of our third visits, and this is what the study is requiring from everyone, and people have done great. The missing data doesn't look bad, but you may be one of those that gets reached out to that says, oh, when we ran your blood sample, it turns out it wasn't a good blood sample and we need to get another sample for your DNA, or we need another sample of the blood. So there's some missing data, but overall right now it looks very squeaky clean, which means that everyone has done an excellent job of getting all the data. Just to give you an indication, we have to check, even if there are 600 and some variables, we have to check every missing data point. So if you skip one item, we need to make sure that you chose to skip that item and it wasn't just accidentally forgotten. So everything in our protocol has to be checked and double checked by quality control reviewers to ensure that we're doing the research in the way that is the best possible research for spending money from the FDA and the NIH. So this is just an overview of where all that data goes around. Just to start with, the coordination center are the people that you hear from in the info box, or that may be setting up to train the sites or work with the sites to help them get going. They're also the ones that then facilitate your genetic counseling and get your CLIA certified gene test back. And we are the ones that work directly with the IRB, the ethical oversight boards, and the NIH or the FDA for that grant, to ensure them that we're doing our best. And so far, we've had a lot of meetings with the NIH and the IRB both, and I consider them both being amazingly supportive of this study. They really are excited that you guys have really come out to make this work, to understand what's going on in CADASIL for North America. We work closely with our clinical core, and the clinical core is all of your fabulous neurologists. So it's every site's neurologist works in our clinical core, and we may send questions to them. Like if something does show up in any of your data that we're concerned about, we're going to send it right back to the clinical core and say, you know, we saw this thing on an MRI. Thankfully, we haven't had this happen very much, but it has happened in my previous, multiple decades of research where someone's concerned. We want to look at this thing on your MRI, make sure it's just something you had from birth, nothing we need to be worried about. We'll have the whole clinical core adjudicate about it. They'll discuss it, they'll review it, they'll decide what to do, and they will get back to you if there's anything that's concerning. So don't worry that the data isn't being looked at, because it's all going to be looked at, even if it's just being looked at for research reasons. And we'll be talking about that a little bit more later as well. And then that's where you come in. So all of these work together to get all of our study sites up and going. And these big thick lines are to show where you come in. You go to one of our study sites, your blood will go to this is the National Central Repository for Alzheimer's Disease, which is the National Institute of Aging funds part of this research. And so the repository that we are using is the same repository they used for the other neurodegenerative diseases like Alzheimer's disease. And they also have the biorepository for stroke and movement disorders. So Parkinson's disease, Huntington's disease, this same Indiana group is an excellent place to store our data. When we hit the number, the magic number that we wanted for baselines, we requested that they ship samples to have them analyzed. So this is all the work that's ongoing right now today as we speak. Those, as many as possible samples, that's how we already know there's some blood samples that didn't work, is we asked every one of those 550 samples to be shipped to a genetics lab for sequencing of the entire Notch3 gene. And we also asked that they be shipped to a biomarker lab for measurement of either central nervous system biomarkers or inflammatory biomarkers. Those are blood markers that show that your brain is reacting to something, and we need to get those levels to better understand what can be used to advance treatments and improve care for CADASIL. So this is ongoing right now. And when they get their findings, they then will send all these findings back to our database. So the database is here. This is a collaborative, which is what the CO is, collaborative informatics and neuroimaging. I don't know. I thought it was center, but that's not center. So collaborative, I'll work on that. I'll get back to you. But anyway, let's call it our database group. This is in Atlanta, Georgia, and they have all of our data. So all of this data that's being analyzed needs to be shipped up here. So they're going to get a huge group of imaging data. They're going to get your entire whole genome sequenced and exomes, and they're all going to go into the database. And then these are blood levels, and I just used for a display, the little blood levels they give you when you get your blood drawn, like if you have your cholesterol's here and they say, if it's up here, you're out of the limits of normal. So we're going to also get those blood levels of all these central nervous system biomarkers and inflammatory biomarkers. So all of these will go into the database. And then as soon as you go to your site, they send all of those tests that you take, all of the computerized tests, all of the images goes into this informatics database, and that goes directly there. So that's already been there, and that's we've been working on, what they call data cleaning. So that's how I know that they're going through every variable, and they'll get back to your site and they'll say, oh, there's a couple items here that aren't filled out. Why is that? And then we'll figure out why it is to make sure that we have the best data possible. Now, that doesn't mean that you are the boss. So if you need to skip something, that's okay. We just want to make sure there isn't anything that we skipped, so that this database should be as complete as possible. Then once we get the database, we do two things. All the images have to be analyzed, and we have at least 8 outcomes, but now we have more because we've been getting additional grants. As I shared, we have 2 additional imaging grants, and we have the retinal scan grant. So in addition to these 8 outcomes we already were planning, we're going to have more outcomes. And then once we get all this data pulled together, it will go to biostatisticians, and they'll start testing our hypothesis. And this just reminds you what we wrote in the grant. We want to characterize CADASIL for all of North America. This will mean, what does it look like cognitively, sensory, motor, mood, organization, decision-making, every symptom you have, we need to better understand it. We want to understand every neuroimage, all of those 8 outcomes plus the new outcomes that we have, which I'll also talk about. We also want to understand what blood biomarkers might be indicative of something we could treat and try to intervene upon, and what blood biomarkers might just show us what the progression of disease is, because we don't know how to stage the CADASIL disease. And as you know, it's a lifelong disease. You have the gene from birth. So we certainly need to know what stage people are in, because you might have different treatments at different stages. You might have a different treatment when you're 20 or 30 than you're going to get when you're 60. So, and that's going to be really important for us to understand. So we will be staging these. Sorry, I keep messing it up. So we're just trying to develop a staging system, get all of these biomarkers, and then we'll start to see which of the biomarkers can be what's considered prognostic. So that what do they predict? Is there some blood test that can predict the people that are going to have a bad stroke? And what can we do? Do we take those and we give them a separate treatment because they're at risk to have a stroke soon? So that's what we want to look at, is what of these measures might be predictive of something that we can intervene and develop treatments for. So we're also going to look at additional genetic influences. We're working with a fabulous genetics group who does polygenic risk scores for small vessel disease and vascular cognitive impairment in general. So we're so lucky to get some of the top researchers in the world working on this grant with us. And then, of course, we'll look at environmental factors. There's controversy about, well, we really shouldn't treat CADASIL like other strokes because it's different, and we shouldn't treat all vascular dementia the same because they could be different. But I'll tell you why this grant could change the world for everyone with vascular cognitive impairment, is that these different mutations do give us different presentations of disease. And so we are really hopeful that it's going to give us indications of many efforts that we can move towards for interventions in vascular cognitive declines. I think I touched everything. Yeah. The other thing is we will look at interactions, because of course, if you also have some Alzheimer's disease in addition to your vascular cognitive impairment and dementia, which is what VCID is for, then, you know, there may be different treatments that we want to be able to give people that have both, because it turns out the most common secondary dementia after Alzheimer's is vascular. So we have a lot of people, the numbers have been from about 60% to up to 85% of Alzheimer's cases at autopsy had a vascular component. So looking for that interaction is going to be critical to best understand how to treat and manage your disease in late life as well as in early life. Okay, so what are we doing now? Well, I kind of started to talk about this. We're doing the DNA analyses. We're cleaning out all of the data. We're already starting to describe who we have. Who are these 556 people? We're starting putting the MRIs through image analysis. So we're going to get the outputs of all these different MRI measures. And we're also running the biomarker levels. So we'll at least know, for biomarkers, we already know that some other disease said, oh, this is a really good measure. We will have those in CADASIL as well to compare. And I'm going to have a few slides to show you what we can compare it with. This is international data. It's CADASIL gene mutation by country. So if you look along this list, all of these countries have a CADASIL group, research group that's working with them. And they're trying to do countrywide studies in each of these countries. And we have met them all. Yes, we have. So we're working very hard and working worldwide together with people, because only together can we maximize what we're going to learn and really expedite getting treatments and ideas for how to have the best treatments and the best life possible for someone with the gene mutation for CADASIL. So what this shows you is a very complicated slide, but it shows you all of these studies have a CADASIL. And then down here, it shows you, these are just genetic studies like all of us in the US that say, anybody that can volunteer to be in this genetic study, what do you got? And UK has a biobank. NOMAD has a huge study. These are all studies that are very large banks where people have donated their genes, their biologicals, their brain imaging to learn about all diseases. So everyone shares these databases across cancer, across neurodegenerative diseases, across stroke, across head injury, across everything. And what this chart shows is, if we looked at all of these people in these studies and all of these people in these studies, how many of them will have a gene mutation for CADASIL. So what we're showing here across the bottom are the 34 epidermal growth factor like domains. So the 34 domains that you can have a gene mutation in by having CADASIL. Your gene mutation might be here. Your gene mutation might be here. So what this shows is where are most of the gene mutations? And you can see most of them are in the domains of 3 and 4. These are by far the highest, except there's some differences across countries. If you notice this lavender piece, Taiwan has a lot of people with a mutation in 13. And they have it called 13.5 here, just to specify that this is a very specific mutation that occurs in Taiwan. It does tend to present somewhat differently. It has more strokes, large vessel and small vessel strokes, than some of these other mutations. But this is why we need to get every domain mapped. So we aren't just mapping the most common ones. We're mapping everything in the Notch3 gene. All 34 domains will be mapped in everyone. And we will be able to have a color. We got to find a color that isn't already here and add to this worldwide graph, because what it's showing us is that it does differ by country. Some countries have a lot of one mutation. Another country might have a lot of a different mutation. This happens to be Germany here, that has a lot of 4s, probably the most of all the countries. But other people also have a lot of 4s. And so far, our data team told me that our most common is 4, but these are based on self-report. So I can't really report on just the few hundred people that had their own exact gene mutation. So we're going to get this entire thing mapped for the entire 556, and we will be able to report back to you how many mutations are in which one of these 34 domains. Now, these are also important because they differ in how they express the disease. So I know this is another busy slide, but what I want to start to communicate to you, we're going to be as open to you about the data as possible, and then you be as open as you can about what should we design for clinical care. So this is what those other countries did in those studies. They didn't just share the mutation, they shared their whole mutations, all their data, and then they shared how people are doing. And what they determined from that, this is a publication from just a couple years ago that was a worldwide collaboration. We weren't able to do it because we didn't have our cohort yet, that shows some of these genetic mutations have a worse outcome than others. And right now they're calling them high risk. So the EGFR domains that are high risk are colored this light yellow color. So all of these, these are all light yellow. Those are considered high risk. They have a more rapid rate of progression and a more severe presentation. These are medium risk and these are low risk. So you see they've been colored differently in this slide, and we're sharing our data worldwide so we can understand when you go to get your gene test, do you want to know I have 11 and that's considered one of the high risks, or I have 13 and this is considered one of the medium. Actually, that's really low. Well, it looks like it's colored medium, or do you have a low? Everyone's going to have their own opinion. No one's going to force you to have information you don't want, but we do need to know from you, how should we set up the sharing criteria? What do you want to know? If you have a right to know if you want, and we don't have any guidelines set up. So we need this group to work together to set up guidelines. Right now, most genetic tests do not give you these predictions. They just tell you yes or no, and here's your gene. But this is where the worldwide group is moving to, is they're now labeling these 3 risk groups: high, medium, and low. So we will have data, hopefully by fall, to contribute to those estimates. So why are we doing all of this? Well, we're doing all of this because we want to make life better for people with CADASIL. No matter where in the family you are, whether you're the gene negative or you're the spouse taking care of someone that has the gene mutation, or you're living at risk but you're still young, why are we doing research? We want to have the best healthcare possible. We want to find treatments that will either delay the onset or slow the rate of progression or keep you as healthy and as free from symptoms and distractions and capacity loss as possible. So Elizabeth did a great systematic review and found some review of the clinical studies that are out there. These are she looked just for reviews of all the studies that are doing clinical trials of anything for vascular contributions to cognitive impairment. So she found 118 studies, but out of these, only 63 were interventional studies. So we were probably counted in this, as were the NIH study and the Mount Sinai study, because that would be 3 of them would be our observational natural history studies, where we're collecting something for biomarkers or to improve how quickly to understand mechanism for treatments. So we're all included. But out of those studies, 63 of them were interventional. And the remarkable thing is, over 19,000 people were involved in these studies. So we want these studies to start to include CADASIL. We want to start to understand, do the current Alzheimer's drugs work in CADASIL? Do other treatments they give to people with other types of stroke work in CADASIL? We can't do that without the research that we're running. The FDA says you can't run a treatment trial if you don't know what's going to happen to people at visits 2 and 3. They won't let you try experimental drugs on someone if we don't know what's going to happen without the drug, because how would we know if it's working or not? So this is key. You're being part of groundbreaking research for North America that's going to change the way and how we can set up clinical trials to start to examine treatments. So out of these interventions, 50 of them are pharmacologic. 5 were some physical agent application, and 7 were rehab approaches. So we have a ways to go. There are nothing that's come out of this yet in terms of an approved drug for vascular cognitive impairment. So you're not missing anything yet, but we do want to be part of the solution and start contributing to testing interventions and treatments and understanding the mechanisms. Okay, I think people know pretty much what clinical trials, but I just want to give you a quick update that the first thing we look for is safety. Nobody's going to let you try anything unless you first show that it's safe. And we do this in a really small number of people. The next thing is, after that we show that it's safe, then we have to say, well, does it improve? And that means, does it help people either live longer, delay the people, or does it at least help people feel better? Okay, so those are the main questions. Do you feel better? Do you live longer? Do you have a better quality of life? Now, an intervention can be lots of things. It can be a drug, which we're most familiar with. It can be a device, like they implant devices in your heart to measure abnormal rhythms and to adjust rhythms as needed. They may implant devices in the brain to stimulate networks or to stop seizures or to stimulate networks that are dying due to disease. There may be surgeries they can do to either clear out areas that are clogged or fix things that aren't working as well. As you know from cancer treatments, there's radiation therapy, and where we're trying to get the cells to die or stop producing what they're doing. And then, of course, there's diagnostic procedures. And the biggest question from a lot of vascular disorders is what matters and what doesn't. it's hard to do all the things they recommend you do for a healthy body. So sometimes it helps if they say, okay, this is the best one for you with your disease, and this is the best exercise for you, and this is the best diet for you, because we can't try all of the ridiculous diets and modifications that are out there. So this is going to be important for us to understand so we can best guide you. And it might be different. These might be different for different mutations. It might be different for different ages. So we have our work cut out for us. This shows you an example of this is made up data. This isn't real data. This shows you that MoCA score, which is the Montreal Cognitive Assessment. And this is the way they do clinical trials in like Alzheimer's disease and all the other neurodegenerative diseases. They start a trial and then they measure how well people function or how well you perform on a certain task. And right now, then we have to get this line measured that shows how fast do people decline? How fast do they decline in their speed measures, which we already have a little bump that people are a little slower. How fast does that go? And then is the only way we can determine if we take this pill, is this different in a significant way, statistically significant? So we need to know what this is in order to try any treatment. We can't just try a treatment without knowing what happens without the treatment. So this just shows, again, it's so important that we get those longitudinal visits in and that we understand what happens naturally in this disease in North America, because it's different in every country so far. Okay, quick shift to give you an update. We are looking at flow in 2 different of our scans. We're looking at the cerebral blood flow, and we're looking at one of the studies, it's reactivity. So we literally ask the person to do different breathing patterns to see how your brain reacts to those different breathing patterns. So this is all about reactivity and blood flow. These are 2 of our grants. We're also doing blood biomarkers as part of the parent grant. So we're looking at any biological markers that can change. The FDA grant is saying, wow, if we could just measure your retina instead of measuring the whole brain, and that can predict how you're going to do or going to predict who's going to have a TIA or an event or a seizure, that would be cheaper and faster and easier than an MRI scan. So that's what the FDA is interested in. And then we did just start wearables. We've just started giving these watches out to people so we can see how it's going to impact your day-to-day life by measuring your activity levels, your sleep, your circadian rhythms, and other health indices. This just tells you we've had over 200 people that were interested in our genetic testing. Not everyone followed through, and that's fine, because they were willing to be considered for it, to be in the study, and you're the boss of your information. You are the boss. You get to choose when you want that information. And if you change your mind, that's completely fine. So we have, of the 200 referrals that we're going to go through genetic counseling, 70%, so most of them agreed to get the information, but some of them said, you know, I don't want to know. I just want to live my life and not know what that outcome is. And everything's fine with us. We really want to work together as a team and not have to have you change any of your decision making. This is another big piece, is that I want you to hear, is that we are listening. I've had several people, not just of our sites, we've had several sites that people have said, why can't you share my data? The reasons might be, I did the same test for the NIH intramural program, or I did the same test at Mount Sinai, or my doctor is going to have a new scan for me when I go see him in the fall. Can you just share your scan? And our answer is always, we want to share everything. But there are other guidelines. And the National Academy of Science, Engineering, and Medicine says we can't share unless it's validated, which is a very lengthy process dictated by the FDA, and actionable, which means there's something to do. Now, we don't have a treatment for CADASIL, so it's obviously not actionable because we can't use a predictive biomarker and tell you, oh, you should take drug B or drug A or drug C. There isn't anything to do. So right now we need data to say to the national academies that this is what the people want, and this is how we're going to do it in a way that's safe and valid. So right now we are starting a new grant. We're asking you to give us pilot data. We don't have the grant. We're just going to write it and say people want us to share more data than we're allowed to share. So please get us the data to show them that you want the data back. So our grant, right now we can share among studies, but you'd still have to do a consent like you would be releasing the information. And then it can only be the research data that's shared. So it's very limited, and you can only share with professionals that are trained. So I can't give you the data unless you have, in my case, a PhD in neuropsychology. In Dr. Litzev's case, an MD with a specialty in rare disease and vascular dementia. So we can only share with people that are trained. We need to determine how we can share beyond these limitations that the national academies give us. And so I would like to ask you to complete the survey. We'll be putting it out just an email. You could do it at home, but we need to know your ideas of, would you like us to share more information? What do you want us to share? The scan, the neuropsychs, the cognitive, the diagnoses, the sensory, and then why? Why is it important to you? Just to help make decisions about, your career planning or your financial management, or what kind of insurance to purchase, or because we can't give it to you because we have a treatment. So that's why we need your input. And the other big ask on today's talk is just anybody that'll volunteer for the retinal imaging study. We can only do it at 4 sites because it costs a very fancy camera that costs like $12,000. So we could only afford to put it at a couple of the sites. So we will fly you to the site and give you a hotel if you're willing to do the study. So please reach out to our team if you're willing to do the retinal imaging study. You also have to do your regular study, but we really need volunteers to do that special study right now. And here is where you can submit all your questions, and always you can reach out to us for any question or concern that you have. And I can see I'm running out of time, and I think I'm done. So let me see. Oh yeah, if you join the registry, we are going to keep you apprised of all the research that's going on in the whole community. So we like to inform people, not just of the research the consortium is doing, but all of the research and all of the initiatives, so that we can work together as a community and use teamwork to make us a strong group, so that we can expedite getting our clinical trials out, expedite having the FDA know about us and who we are and what we're doing. And if you can sign the registry, it just says, all it says is you're willing to be contacted. And then you can say, oh, I don't want to do whatever. I don't want to do a skin punch study, or I don't want to do a retinal study because I'm sensitive about my eyes. But it just gives us the ability to maybe even just do a survey study that asks you your opinion. So please sign up. You just use this, click on this, so that we can invite you and you can sign up, and then we can show the FDA, the NIH, and all the powers that be that we have people willing to work hard with us in this team. I'm going to leave that one up. Oh yes, just we're in this together. There's a couple of things going on for fundraising events. Both of these groups, the $1 Million Bike Ride and the Think CADASIL group, are raising money that's going directly back into research for CADASIL and care for CADASIL. We want to do both. We want to provide support groups. We want to provide doctor lists. We want to provide resources so that no one feels alone out there. And this is a big lift, and we're working hard on it, and Cure CADASIL is working hard on it. And now we have $1 Million Bike Ride and Think CADASIL, and we have many group Sisters Hopes that are working on it, but let's all work together to build the best network we can for one another. So the next webinars are here. Previous ones are here. They're usually recorded. You can just ask for the recording in our info box. I'm going to go back up to that. But this also shows you our study site, our YouTube, our Instagram, our Facebook, and the research registry again, so that we can get as many people involved as possible. And I think that info, oh, good. There's the info at CADASIL Consortium again for questions. I can stop there. Any questions you
Thank you.
received?
We did receive questions. I did promise folks we'd kind of end on time. I don't know if it's okay to go over, or I can.
No, we
promise
should
that
end on time. I'm sorry. You can poke me.
The questions were great, and you actually answered a few of them already. So for the couple that didn't get answered, I see you. We've got you. I will consult with Dr. Paulsen, and we will reply to you via email. I just also want to remind folks that this webinar has been recorded, so it will be available to individuals after the fact. Anyone who's registered will have access, and we also will get that posted, this recording posted on our website and on our YouTube channel. But I am so excited to hear how far we have come with all of this. It's been beautiful to witness and just really inspiring with where we're headed. And I'm hoping to hear from some of you folks that may want to join the registry or see what else we can do to keep you involved and connected. This was great. Thank you so much.
Now, so the questions were more than 2-minute answers?
I'll give you a quick.
Well, I'm just thinking, is
you
Dr.
answered
Lutz
about
able to talk too? Because if there's a medical question, I'm going to need help from Dr. Lutz.
Yeah, well, one of the questions is about whether if somebody was denied enrollment because of interference with the MRI, like an issue with metals in the body or something like that, is it possible that they still might be able to participate in future research?
Oh, definitely. In fact, even our own research, what we want to do in the renewal, right now we have to follow these 556, and we're going to try to keep it at 500 with MRIs, but we want to follow everybody because some people, dental work turns out really common. And so what's happening is we're going through the scans, we're figuring out if dental work really bothers many of those 8 outcomes. And now we have 11 outcomes. But what we're finding is it doesn't interrupt all of them. It might interrupt a few of them. So we are doing the cost analysis so we can share with NIH how we're spending the money, because we have to be responsible. So the ones we know we can do are the people that got through the whole thing without metal. Then we're going to go through the people with metal and see which ones of those we can continue to follow. And even if you can't do the MRI at all, we still need you, because that is going to be a different group. So yes, there's definitely plenty to do. There's so much to do. We just need to keep writing those grants, and hopefully NIH will be able to keep supporting us.
Thank you.